Hi everyone. This week's lesson centered around electricity and magnetism in a fifth grade classroom. First of all, our district requires our science lessons to be framed around the workshop model. So all of these lessons started with a mini lesson and contained a work session and a closing session, which was often an assessment piece. The standards and objectives that go along with this week-long lesson were related to electricity and magnetism. Students obtained, evaluated, and communicated information as they investigated electricity. They learned the difference between naturally occurring static electricity and human harnessed electricity. They designed circuits, they explained the components of the circuit, and they planned and investigated experiments that tested common materials as insulators and conductors of electricity. The ISTE standards that go along with this lesson are empowered learner, where kids took an active role in demonstrating competency. They were also knowledge constructors. They used digital tools to construct the knowledge, produce artifacts, and make meaningful learning experiences for themselves and for others. Next is the lesson objectives and the overview. Each day the lesson began with a mini lesson. On day one, we started with a phenomenon where kids generated questions. They wrote them on sticky notes, and we created a question board, which we will and did reflect on as we went through the week. It's meant to drive the learning, and it's also meant to give students ownership in the learning, behaving as scientists behave. For the other 3 days, we had video mini lessons on electricity, types of circuits, conductors, and insulators, and on the final day, we had a Nearpod that incorporated all aspects of the workshop model in one lesson. Next, we're going to talk about the workstations. The work sessions, students rotated daily to different stations. It allowed them to learn from reading a digital assignment in CTLS, which had an assessment component in it, investigating, testing circuits, insulators, conductors, and static through the FET simulations. Those were really the creative aspects and the building aspects of the activities. And then there were hands-on labs on static electricity where students had to reflect. They had to experiment and reflect and write down their observations and their discoveries in these interactions with static electricity. The final lesson, again, was a Nearpod that incorporated all of the aspects of the workshop model, including mini lesson, work session, and assessment piece. The digital tools that were used during this lesson was CTLS, which is our learning management system. The reading assessment was embedded in the student coursework, and students had to read and they had to respond with regard to what electric circuits and some aspects of that topic. The second digital tool we used that was the real creative part of this was the FET simulations, where we used FET to simulate static electricity with balloons and sweaters and walls. And we also built some circuits and tested some common materials as insulators and conductors within the FET system. Very creative. Students had to do some thinking, collaborating, and creating with regard to the FET simulations. The last digital tool was Nearpod, and it was on magnets and magnetic fields. It sort of bridged the information about electricity and magnetism together, and there was a final time to climb assessment at the end of that Nearpod, along with videos and note-taking and matching components. The major challenges of this lesson, of course, were time constraints. We're getting close to testing, and all of these things felt very, very short and condensed. Students who had to work independently, they sometimes had trouble with self-control and independent working. And then when we got to some of the FET simulations, there were some kids who had trouble being curious, being risk takers, and using the different aspects of the program to test out materials and test different things. And that was a challenge because I was occupied with the lab activities. All in all, it was pretty well designed, but there are some improvements that can be made. It would be better to do this over a 2-week period and possibly a little more hands-on teacher monitoring. So that's all for this lesson. I hope you enjoyed it. Thanks for being here and sharing.